Hi, I'm Miss Hearn. Let's get started. The basic idea of integration is that you need to get it into a form that matches something you can integrate, right? And at first all we had was simplifying algebraically. Now we have simplifying algebraically and we have substitution. So we have a couple of options. But usually if you can do simplifying algebraically, that's preferable. Usually. Could we simplify this one algebraically? I prefer to think of it as dividing each part, but you can also think of it as changing it to e to the negative x and distributing. But I'm going to distribute it as a quotient, and you should turn out with the same thing in the end, right? So when you divide e to the 3x by e to the x, what happens there? You're subtracting 3x minus x, right? So when you divide like bases, you subtract the exponent. So that's going to be e to the 2x. What about over here in the second term? E to the x just cancels there. And then what about over here? Well, that one we have no choice but to think of it as e to the negative x. Now, there are three terms. If we can just go ahead and integrate, great. But in this case, we have a little compensating to do because we have an e to something other than an x. It's still 2x here, right? So we're going to have to use a substitution. And we're also going to have to use a substitution over here in the third term, but this time it's e to the negative x. That's two different substitutions. So let's just, to keep our minds clear on what's happening, let's break this up. This is going to be the integral of e to the 2x dx plus the integral of 3 dx plus the integral of 6e to the negative x dx. And this first integral, what would we let u equal? 2x, because we want e to just a single variable. So we're going to let u equal 2x, in which case du is what? 2 dx, right? Do we have a 2 dx here? No. So how do we fix that? Good. We're going to put a 2 inside and a 1/2 outside. Okay, so making that substitution, then we now have 1/2 the integral of e to the u du. All right, plus, what's the integral of 3 with respect to x? Just 3x, right? Plus c, but we're going to put the plus c way out at the end. They each are going to have a plus c. But we're going to put just 1 at the end. All right, now 6e to the negative x, you can think of the 6 as being out front. Okay, what are we going to let u equal in this case? Negative x. And I'm not going to call it u just so I don't confuse it. Let's just call it v. So v is negative x. Then what is dv? Negative 1 dx. Do we have a negative 1 dx? No. So what do? I'm going to squeeze a negative 1 in there. Also a negative outside. So we don't change the value of the integral. So that leaves us with negative 6, the integral of e to the v dv. All right, let's come back to this first integral over here. This is going to be 1/2 e to the u plus we have 3x minus 6e to the v plus c. But of course we want x's, so we're going to substitute our u equals 2x in here, and our v equals negative x in here. So we're going to have 1/2 e to the 2x plus 3x minus 6e to the negative x plus c. Okay, which is equivalent to the solution that's typed here. I hope you found this video useful. If you did, please remember to like it.